Welcome to BKW Physics. I'm Mr. McConnelly, and today we're going to do something, another mathematical review type of lesson. It's just algebra, it's just rearranging equations. And I think what confuses some physics students is in math class you always used x's and y's and z's. And you're able to rearrange the equations and it seems fine. But when you get to physics class, we used all different letters, and I just took a sampling of different equations from your physics reference table that you will eventually get if you're taking physics, high school physics. And I picked out some equations that look a little strange or they have a lot of different letters in them. But what you got to remember is the rules of math still apply the same way. And just because there's n's and these weird things that are lambdas in this equation, that does not mean that you do anything differently. Yeah, Greek alphabet, lambda. Right after kappa, right before mu, lambda, lowercase. Or you can say lambda. I think that's what McCoy said, right? So, anyway, we're just going to take these, and what I've done is I've circled one of the letters in red, and what I mean is I want you to rearrange it and solve for that letter. So I'll do them with you, and if you can just jot it down for today, that would be great. So, in this equation, it's a work equation, and it's got a v and a t and an r. You don't know what any of that means right now. But I want you to solve it for the r. I want r equals. And right now, the r is in the bottom. So to get something out of the bottom is a first priority when you're rearranging. And the easiest way to do it is multiply both sides by the r. That'll cancel here, and that'll leave you with r times w equals v squared times t. So I've moved it to the top. And all of a sudden the problem doesn't seem so bad anymore because I want the r, and all that's blocking me is the w, and to get rid of that I can just divide by the w. And whatever I do to one side, I do to the other side. Cancellation, r equals v squared times t over w. I've rearranged it for r. Now, will I require that you show all your steps, like on a test? No. But I do need to be able to do it, and if you have to start like this, where you show all your steps, until you're more comfortable, do so. Once you're comfortable, and you can zip down to this answer, rearrange doing some of it in your head, that's fine, go ahead. The next one, I'm also asking you to solve for an r. In this case, it happens to be a lowercase r, which means something different, but don't worry about that. And what I need to point out about this equation is that's f sub g. In other words, it's like these two are attached. This is all one term. You don't break it up. It's fg. Okay, it's one thing. It means force of gravity. And I'm also asking you to find an r, and the r, just like the last problem, is in the bottom. But it's got an added twist in that it's squared this time. But do you think the same trick can apply? Can I multiply both sides by the r squared to get it out of the bottom? Sure, still works. So we're going to multiply both sides by r squared. We got r squared times that fg thing, which is all one term, equals big G m1 m2. Remember, I'm looking for the r squared, so I'm going to get rid of the fg by dividing both sides by the fg, which will cancel here, give me r squared equals g m1 m2 over fg. Now it seems like we're done. We're not quite done. Because that's r squared, and I asked you to find just r. So how do you get rid of a square? What's the opposite? The square root. So I'm going to take the square root of both sides, and I'm going to leave myself with r equals. Now I don't have a way to really simplify this, so it's just going to be a radical with a bunch of variables underneath the radical. Boom, like that. That's my final answer. Seems a little awkward and messy, but that is the rearrangement in this case. Moving on to the next one. This is a potential energy of a spring equation. Again, PE with a sub S, that's all one thing. Don't try to separate those. So that's one thing. And we're trying to find find the k. Now this time the k is on the top, so we don't have to like get it out of the bottom or anything. But there's other stuff blocking it. How do you want to get rid of those? Well, maybe the easiest thing would be to multiply both sides by a 2. If you multiply both sides by a 2, that 2 will cancel out that 2, and you're left with 2 of these PE of the springs equal a k and an x squared. So I've gotten rid of the 1/2 by multiplying by 2. And then to finish it off, to get rid of the x squared, I can divide both sides by x squared. Cancel them out on the right side. Leave myself with 2 of these PE of a spring things over an x squared equals a k. Done. Again, I'm showing a lot of steps. I'm showing all the details. You don't necessarily have to do that if you're more comfortable. Now the last one is fractional, and sometimes fractional things mess people up. There's a lot of approaches you can use with this. I'm going to show you 2. There's a cross multiplication approach. You've learned that when you got the fractions you can cross multiply. So let's do that one first. Let's do n1 times lambda 1, lambda, equals n2 times lambda 2. So I cross multiply. Remember, I'm looking for this one if you forgot. All I got to do now is divide by the lambda 1. Divide by the lambda 1, whatever you do on one side, do the other side. These cancel. You get n1 equals n2 lambda 2 over lambda 1. Okay, that's one way to do it. But not everyone is keen on the cross multiplication concept. So why couldn't we treat it back to like our first and second problem? We're trying to find a variable that's stuck on the bottom. So method number 2, we'll call this method number 1. Method number 2, if you got something on the bottom, if you multiply both sides, so let me rewrite it so it doesn't get confusing here. This is method number 2. If I multiply both sides by n1, that'll cancel it from here and leave me with n2 equals lambda 1 over lambda 2 times n1. Now what was I trying to solve for? I was trying to solve for n1. So how do I get rid of this ugly little fraction here? You can multiply by the reciprocal. That's a good call. So if I multiply by lambda 2 over lambda 1, I'm kind of squeezing it in because I'm out of space. Lambda 2 over lambda 1, this would cancel out on this side. I would be left with n1 equals lambda 2 over n. It's supposed to be a lambda, isn't it? I screwed up here. I wrote an n and I tried a lambda. Okay? So lambda 2 over lambda 1 times n2. Which, by the way, notice is the same thing. Now, in this case, I wrote the n2 and the lambda 2 totally on top. And in this case, I wrote a fraction times n2, but that's the same as having it on the top, right? These are 2 ways to do the same problem. In fractional problems, you got to choose how you're going to do it and pick whatever way you're comfortable with. So for today, those are some examples.